let's do some comparisons with some temperature drop across the condenser. And here's my ambient temperature right now. Our outdoor bulb temperature at this point, taken from this little thermistor right here, is 66 degrees. Our suction line, liquid line temperature is what we want to look at. It's 79 degrees. So this is our ambient, and this is what we're over after going through the condenser and going through the subcooling passage and coming out at this point right here. So let's move it right here. Let's see if we could get, if I can clamp on a little colder. This is right out of the condenser. So that's after it's gone through the receiver dryer. It's come out these last few tubes here that are the subcooling tubes. That's like 5 or 6 of these little lines right here. Actually, let's see if I can count them. This circuit is harder to count, but I'm going to say 1, 2, 3, 4, 5, 6, maybe 7 of these lines, because it'll come out right where that little block is right there. That's most likely where it's coming out right there and hitting this little passage. Is blocked up here and is dropping into these lower tubes. It's coming across and then going right into here. So from here it's a vapor. It starts condensing to a liquid. It enters right here. It goes up into the receiver dryer through the desiccant material. It dries out. It goes through a filter, a screen, and then the liquid settles out here at the bottom. This is supposed to be solid liquid or almost solid liquid. And then by the time it comes through here, it's supposed to be stacked up and backed up into here as a solid liquid. It should be a solid liquid at this point. So at the exiting of the condenser, we are now 80 degrees. So let's take this and let's see what we're entering at. Here's entering. There we go. We're on entering. Now this is the temperature of the vapor high pressure refrigerant entering the condenser. 112, 113, so we're 33 degrees higher. So we have a temperature drop of 33 degrees. It enters at 113, 114, and it exits at 80 degrees. That is the temperature drop across this particular condenser at this temperature with this fan arrangement. Now, it'll change depending on condensers and fans. Like this fan, from what I can see, is a constant. It's not going up and down. It's staying constant. Some fans cycle. You've seen videos where I've done fans where it will cycle all the way up to 270 degrees. And it'll turn off the fan. It'll let the high side pressure go up to 270, 260, some are 240 degrees. It'll energize a switch. It'll turn on a fan until it drops to about 175, 150, and then it'll turn off the fan, and it'll keep doing that. You can't get a steady reading on something like that. Then you have variable fans that aren't on and off, but they're variable. And then you have something like this, which seems to be staying constant at a fixed speed, and it's holding everything really stable. So 118 degrees going in. See what if the temperature changed. Let's watch that fall as the temperature clamp cools off. It has to get rid of some of that heat because the clamp, the sensor, actually got hot from being on the hot side. And we're approaching that 80 degree again. Probably up a little bit because it's been running for a while. Now that's with the doors closed, no load over the evaporator, and I think I have it on recycle. So we're coming out at 80, we're 114 going in. So let's put a load over the evaporator and let's see what it does to the discharge temperature of the compressor. So I'm going to open up this door. I'm going to put it in fresh air mode. So now we're going to take the air from outside, not the cooler air from inside that's been cooling off from the evaporator. Let's see if I could make this, drive this temperature up a little bit. This is a really cool day to be trying to do this, but we might have some results here. Well, we can see we already went up a few PSI on the high side. So since PSI, pressure, is related to temperature, let's see if we went a few degrees up on the discharge. 60, yep, we did. We're up 16, 17, 118, 119 degrees Fahrenheit, 120 degrees Fahrenheit. And why is that? Because the load is going across the evaporator and it's picking up more heat. And because it's picking up more heat and getting rid of it, cooling up, trying to cool off inside, more heat is contained in that massive refrigerant that's coming back and getting compressed. So more heat has to get rejected. So the pressure goes up. And the higher the difference, the faster you could reject heat through the coils or the fins of the condenser. We're still climbing. And we're still climbing. And as I put my hand up here, the engine is getting hotter. We have a hot exhaust right here. The condenser is getting hotter. So the air entering is becoming hotter on this side, passing the radiator. Let's see, the radiator is just lukewarm, it's not hot. And it's going on this side, and this is going in and getting sucked down there, heating up the evaporator, adding heat. We're up to 130. Let's see what our outlet discharge temperature is. We're at 130 on the condenser. Inlet, high pressure vapor. Now we're on the outlet liquid. And remember before, with the doors closed in recycle, we were at 80 degrees, and it looks like we'll probably fall down to about 85, maybe 84. Well, it's going to stay at 86. I'm a degree off. All right, so that's with and without load, and you can see some temperatures. I hope that clicks for some of you guys who've been watching my videos long enough to start seeing these different temperatures and pressure relationships, and the difference between recycle mode and fresh air mode, doors open, doors closed, and these different fans, the way the manufacturers control fans. Some cycle on and off, some are constant, some are variable. Some cars have two fans and they'll keep one on while the AC is on, and then the other will only pulse on and on when a certain pressure or temperature is hit. And then another one might pulse the first fan, and then when it reaches a certain, then it'll go constant, or a secondary fan will kick in at a much higher speed. There's all these variables, and they'll all mess with your pressures and temperatures that you're used to seeing, because they're not fixed. On top of that, this is an electric compressor. It's variable speed compressor, and it varies itself, so it'll mess with things. That's it. I think that's enough for this video in here. This shop is so noisy, my ears are ringing. All right, catch you guys later. See ya.